Hi, in today's session, we're going to be looking at confidential VM, virtual machine, and really, we're also going to be looking at confidential space. So while primarily the focus is on confidential VMs, we can't really have a conversation without actually also talking about the confidential space, right? And this course level sits at the 200 level because it does dive deeper in terms of technical content, right? And when we look at confidential VM and confidential space, what we're really focusing here is around virtual machine security, and it is part of the Google Cloud Certified Cloud Security Engineer certification. So within this module, we're going to be looking at a number of buzzwords, right? And there's quite a lot. So this is a very technical mini course that we have here. And these are some of the actual topics that we're going to be covering, okay? Now, if you look in terms of like the context here, right? Confidential virtual machines, right? When we talk about confidential virtual machines, it's really meeting a specific security requirement, right? Just like shielded virtual machines is, right? And while this course is predominantly focused on confidential virtual machines, we have to keep in mind that the other side of the coin is shielded virtual machines, right? And each of these actually presents two different use cases. So I'll do a different module specifically for shielded VM, but for now, this course is focused on confidential virtual machines, and we'll look at some of the use cases for this, right? Now, where it actually fits in, like when we look at confidential virtual machines, where does it fit in? What is it actually doing for us, right? So when we look at encryption, we have encryption in transit. So that's really basically ensuring that traffic is encrypted from source to destination. So think in terms of like SSL, TLS, HTTPS. Those are some of the protocols that we are concerned with when we're talking about encryption in transit. Is our traffic secure when it's going from one place to another place, right? And then the other type of encryption is encryption at rest, right? So when we store data in the cloud, when it's residing there, we want to be able to ensure that the data is encrypted when it's actually stored on a hard disk or something like that, right? Think in terms of like things like AES 256, etc. And remember, Google by default does encryption in transit and encryption at rest within the actual Google environment. Now, where confidential virtual machines comes into place is basically doing encryption in use, right? So we're actually doing encryption while something is being used, while it's being processed, right? And that is the missing building block here. And when we look at all three, ideally from a security posture and a security control point of perspective, we want to be able to do all three, right? Now, what else, right? So if we look at confidential virtual machines, right, think of these as Google Compute Engine. That's what we're doing. We're doing encryption in use at the actual compute engine level, right? But what else, right? What else does this kind of functionality, right? And it's a little bit outside the course because we only want to focus on confidential virtual machines. But with that said, we can also do confidential GKE nodes, right? Google Kubernetes Engine nodes, right? And again, it's encryption in use, right? And we can also do Dataproc confidential compute, right? So these are basically Dataproc clusters, which basically consist of clusters of confidential virtual machines, right? So when you think of Dataproc, just like a basic 101 here, data procs are basically clusters. They are Apache Spark clusters, Apache Hadoop clusters. That's what the data proc is in Google Cloud, right? So let's just take a little bit of a step back and look at confidential virtual machines and how that actually fits in other elements, right? So as the title of the course says, you really can't have a conversation of confidential virtual machines without actually having a conversation of confidential space. And we're going to get that to a little bit later in the course, right? But remember, when we look at confidential virtual machines, which is basically encryption in use, what we're really doing then is we're extending that concept to confidential spaces, right? So that's where we're going to get to a little bit later on, right? Now, let's kind of like define confidential computing, right? So we know that it's protecting data in use, right? So, while the data is being processed, while it's being used, we're ensuring the protection of that, we're ensuring encryption in use, etc. That essentially is what confidential computing is, right? Um, as part of confidential computing, you get secure boot, right? So what that really is basically making sure that the OS, that the images, that the components are secure, like they're digitally signed, the firmware is digitally signed, that makes sure that there's additional controls in place, right? And measured boot is kind of making sure that the boot integrity, the boot itself is also secure, right? So we're not just talking about protection data in use, but when we think in terms of like Google, they're actually adding additional items with secure boot, measured boot, and it's really think of it as a package. And that's what confidential computing is giving, right? Now, as part of confidential computing, right, what we're doing here is we're protecting with a concept called trusted execution environment, right? And this is essentially hardware based, right? So let's dive a little bit deeper in terms of what do I mean by trusted execution environment, right? So what the TEE, as it's known by the acronym, right, is it creates a secure environment, right? It's creating an isolated environment, right, which prevents unauthorized access and unauthorized modifications, right, to both applications and data. And this is the most important thing, while it's in use, right? So the TEE is basically giving all these elements, and we're going to look in later slides on how it does this, right? So like many things that Google Cloud does, it follows industry standards, right? And there is a confidential computing consortium that defines the standards, etc., to which all these vendors comply to, including Google, right? And it's important because what you want to ensure is that something meets a standard, and that's really one of the driving factors around security in itself, right? Now, so far we've been talking about confidential computing, right? So now what I want to talk about is shift gears and talk about specifically for Google Cloud, Google Cloud's confidential virtual machine, right? Now, it is basically essentially a type of a virtual machine, right? And it's specifically a type of compute engine, which is what Google calls the virtual machine, right? Now, what it's actually doing, it prevents the exposure of secure data and workloads, right, during the actual processing, as we discussed before, right? But remember, think of in terms of we're not talking about regular data. We're talking about confidential, secure, sensitive kind of data and workloads here, right? And what makes, if we look at the magic, right, what makes confidential VM possible is a lot of sophisticated hardware and technology that sits underneath the hood, right? So really, confidential virtual machines, by its nature, virtual machines runs on hosts which actually have the AMD EPYC processors, right? So these processors are cutting edge, right? So these processors have the AMD SEV, which is the secure encrypted virtualizations, right? And these hosts uses the AMD Secure Processor, and it uses a concept called system on a chip, right? So we're going to dive a little bit deeper into these kind of concepts, but for now, think of that it runs on a host that has a lot of AMD components to it, right? Chip-oriented components, right? And we're going to get to these in a bit. It'll let some later slides here, right? Now, at the heart of all this, it uses something called a virtual trusted platform module, right? Now, TPM, right, it's kind of been around for the industry, and with Google Cloud, they created a virtual trusted platform module, right? And it's typically a microchip, but in this case, it's virtual. And again, there's a trusted computing group org. I put the website link there, and that's kind of like spearheading, driving the whole initiatives around TPMs, etc., right? And there is a cost associated with using confidential virtual machines in Google Cloud, right? Unlike confidential spaces, which we'll get into a little bit later on, right? Now, the AMD Secure Encrypted Virtualization, SEV as it's known, right? So there's a number of benefits to using the AMD SEV, right? So it creates isolations, it creates attestations, and it provides better performance, right? So let's dive deeper into these three core benefits, right? So the first one is that, it provides the isolations, right? So imagine, you're creating, or, you're building this virtual machine, right? The moment you create the virtual machines, right, the compute engines, the encryption keys are generated, right? And specifically, it's generated by the AMD Secure Processor, right? So once these encryption keys are generated, right, it has to be stored somewhere, right? And in this instance, we have to install it somewhere to do with the AMD. And in this instance, we're going to install it on the SoC, right? The system on a chip, right? Which is part of the AMD, right? Now, this is really important, like when we look at the isolation aspects of it here, right? So when the keys are generated, when they're stored on the AMD SoC, right, nobody has access to those keys, right? Not even Google. And that results in an enhanced isolated benefit, okay? So first benefit, isolation. Next benefit is attestation, adding specific vTPM attestation, right? So confidential VMs use the virtual TPM attestation, right? So, and the way it works is each time a virtual machine is started, essentially when it boots up, right, based on the AMD SEV, it generates a launch attestation report event, right? So why is that important, right? That actually makes that report is critical because it makes sure that the confidential VM is basically being based and run off the AMD SEV, right? And there are a number of key elements that are included in this report that provides the validation, the confirmation that that is secure, right? And while it's outside the scope of this module to kind of like go deeper in there, there are these reports we can do a deeper dive around that, right? Now, the other benefit, the third benefit is better performance, right? So this performance comes directly from the AMD SEV, right? So imagine kind of like a situation where you have demanding workloads for computational intensive processing, right? Because of the AMD SEV, there's very little degradation, right? Almost like less than 0.5% in performance, right? So that's another benefit of using the AMD SEV, right? Performance. Now, how do you configure the confidential virtual machines, right? How do you enable it, right? It's very easy. It takes no more than a single check button. So when you're creating your compute engine, you basically hit the button, you just basically check a box, and you're basically going to turn that compute engine into a confidential virtual machines, right? Now, if you're going to do codes, if you're going to do Terraform codes, you want to do all the automation aspects of it, it'll be 1 to 2 lines of extra code, no more, right? And the other benefit is that while you're working at the confidential virtual machine level, there are no changes required to existing applications. You don't need to change your applications in any way. Now, that's what confidential virtual machines is, right? So now let's shift gears here and talk about confidential spaces. So how can we take confidential virtual machines to the next level, right? So just keep in mind before we start this conversation, we're talking about data here, right? So what confidential space allows us to do is gives us the ability with confidence to provide sharing of data between two parties. Essentially, imagine the owner, right, and the workload where the processing happening, right? So in order for the sharing to actually happen, there must be some mutually agreed contract somewhere in place, right? And that each retains the confidentiality and each retains their data ownership aspects of it, right? And why, from a security perspective, is confidential space important? Because it's creating a trust boundary here, a trust boundary between the data owner and the workload where the actual processing is taking place, right? And it helps to also build isolation, right? So the data is only known between the workload and the data owner, nothing outside. And again, it uses the TEE that we mentioned before, right, to release secrets only to approved workloads, right? So again, this kind of goes back to that workload, right? So we want to release the secrets only to the workload, and the attestation process of AMP combined with the hardened operating system helps us to protect the data and the workload, right? So again, we're reusing some of the concepts that we used in the previous slides, right? Now, as I mentioned earlier, there is no extra charge to using confidential space, right? So you're only charged for using confidential virtual machines, right? So let's kind of like think of this, like imagine this, that you had an owner and, it was in a specific project and the data was there, and then you had another project where the workload was created. What you would essentially do is create a boundary. So you're basically creating a boundary where the data repository is and where the data is actually being processed, right? So you're taking it to the next level essentially, right? So that's really expanding the scope of virtual machines and creating the ability to exchange data, work with data, etc., right? Now, what data may be exchanged with confidential spaces, right? So in terms of the data that I mentioned earlier at the beginning of the course, right, is, we're thinking about sensitive data, right? Highly confidential data, right? So what is some of this kind of data, right? So we have personal health information, PHI, personal identifiable information, PII, secrets like, that's part of the cryptography aspects of it. That is some of the data we can share with confidential spaces between the data and the actual workload, right? Now, there are three main components to confidential space, right? There is the workload, where the actual work is always there, the attestation service, and the protected resources, right? So while I haven't really gone into a little bit deeper in that, right, I want to be kind of like focusing on these security aspects of it, right? And as you know, roles within security, identity access management, when we look at cloud identity, roles are important in all aspects of Google Cloud, right? So in confidential space, we also want to talk about some of the roles, right? So we have the workload author, right? So in this instance, it is actually responsible for creating the containerized images, but it does not have any access to the data. The workload operator runs the workload in a project, has full admin aspects on the project, and manage the compute engine instances. Again, no access to the data. The resource owner owns the protected resources, right? Access to their own data. So if you look at it, back to that whole concept here, who has access to the data? Where is the trust boundary, right? Where is that isolation that we're creating here? We're creating those through these role types, right? That's what we're enforcing here. So with confidential space, and a really important concept is a trust model, right? So the two roles described on the previous slides are separate, right? In actual fact, the three roles all are completely separate, right? But there's two distinct levels of roles there, right? Now, the whole concept is, if you think of this as zero trust, so in the concept of zero trust, we don't trust anything, right? And we always assume a breach, right? So that's the whole concept of zero trust there, right? So in this model, the trust model is echoing that philosophy, right? So they don't trust each other. The roles don't do that. And the author can also be in a different project, right? So the author and the workloads can be segmented, can be isolated in different projects, right? And resource owners are essentially in a different project governed by IAM, right? So when we think about where the resource owners are, where it's actually being processed, think in terms of that, we can add that wrapper around identity access management, IAM. And that concludes today's module. So thank you for attending. And I put a quick link here so that you can reference the actual location on Google's website for more information on this topic. Thank you. Bye.